Suppose you have a pipeline of three AI agents: researcher, writer, and editor. The researcher does a web search and sends a notification email to your team. Next, the writer starts and it crashes for whatever reason, out of memory error, a bug, or timeout. Now, to recover it, you restart the entire pipeline. The researcher runs again, the web search fires again, and the email gets sent again. So your team just got a duplicate notification. In production, that could be duplicate charge, a duplicate database entry, a duplicate API call. This is not how you build production-ready agentic applications. There is an open source runtime called Agentspan that makes your agent pipelines crash-proof and production-ready. It's MIT licensed, completely self-hosted, and your data never leaves your infrastructure. It's built by the team behind Netflix Conductor. Big thanks to Agentspan team for partnering on this video. If you are building multi-agent pipelines with frameworks like LangGraph, CrewAI, OpenAI Agents SDK, this video is for you. And before you ask, no, you don't need to throw away your framework. You keep using whatever you are on right now, LangGraph, CrewAI, or something else. What I'm about to show you layers on top of your existing code. Just a few lines of change and your pipeline becomes crash-proof. Let's get into it. So here's what we will cover. First, what Agentspan is and where it sits in your stack. Second, why your agents aren't durable by default. Third, before and after code. We will see same agents with and without Agentspan. Fourth, a live crash and resume demo. And fifth, what else you get, like automatic retries, observability, and tool idempotency. Now, to understand what Agentspan is, let's first understand how every agent framework works today, like LangGraph, CrewAI, OpenAI Agents SDK, etc. Your entire agent pipeline runs inside your Python process. Every LLM call, every tool call, every intermediate result, all of that lives in the process memory. And this creates four problems in production. First, a single out of memory error, a deployment, or a container restart will lead to restart of all of your agents from scratch. Second, you don't have any visibility on which agents completed, what exactly did they produce, and where did they fail. You have to dig through logs to find out. Third, rerunning agents and their corresponding tools can have adverse side effects. So if your agent sent an email before crash, it sends that email again on restart. And fourth, if your agent needs human approval, it has to hold a thread open. And that thread blocks for hours or days. And during that time frame, if your process restarts, then your approval state will be lost. Now, LangGraph does have checkpointers like memory server and Postgres server, but they work at the node level. They save state between agents, not within them. So if your researcher agent calls 3 tools and crashes after the second one, the checkpointer doesn't help. The entire node reruns. With Agentspan, every individual tool call and LLM call is its own persisted task. The granularity is fundamentally different. Agentspan separates your code from the execution state. So your code still defines the agents and the tools, so nothing changes there. But the orchestration, like which agent runs next, what the previous agent produced, where we are in the pipeline, all of that moves to a separate Agentspan server. So your process, which was earlier containing the entire agent and the pipeline, etc., becomes a worker. It registers your tool functions with the Agentspan server. The server decides what needs to run, it dispatches a tool call to your worker, and then persists the result of every completed step. So if your Python process dies, let's say there is a crash or redeployment, or if the container restarts, the server still has the workflow. It knows step 1 completed. It knows step 2 was in the progress. So when your Python process comes back up, which we are calling it as a worker, it pulls the server and gets the pending workflows. And the server dispatches the pending work. So completed steps will not rerun, and the server skips them entirely. You also get a dashboard with Agentspan that you can access at localhost 6767. And since Agentspan tracks everything, like every LLM call, every tool call, timing, token counts, etc., you can view all of that data on that dashboard. So it doesn't require any extra step or third-party observability tool. Now, behind the scenes, Agentspan is powered by Netflix Conductor. If you haven't heard of it, you can think of it as a job tracker for distributed systems. Netflix, LinkedIn, and Tesla have been running Conductor in production for nearly a decade, and they have handled billions of workflow executions. Now let me show you the code. Now this is a really simple project. There are 2 files, before.py and after.py. Before.py is built using LangGraph, and it contains a pipeline containing 3 agents: researcher, writer, and editor. After.py contains the same pipeline with the same agents, but it is using Agentspan. Now first, let's go through before.py. At the top, we have a couple of import statements. Then we are creating our chat OpenAI object. And then we have defined a couple of tools here. So there are two tool functions, web search and send email. Send_email sends a notification to your team. Now the email is a side effect. If it fires twice, then your team gets duplicate notifications. Next, we have defined 3 agents: researcher, writer, and editor. Researcher calls both of these tools one by one, web search and then send email, and then makes an LLM call to synthesize the results. Next agent is writer, and we are making the writer crash every time. So I'm simulating out of memory error, a bug, a timeout, or anything else. And in production, this can happen. And then we are building this graph, we are adding the nodes and the edges. And now this is where we are running this pipeline twice. So this is run 1. So we are starting the pipeline, which will invoke our researcher agent, and then our writer agent will crash. So we will handle the exception and move on to next run. And here we are rerunning the pipeline. And then we are counting how many times each of those tools was used. Now let's run it. It's done with the web search and it has successfully sent the email. And then agent 2 was triggered and it crashed as expected. So this is the second run where pipeline got triggered again. We can see that it started from scratch. It executed the same tools again, and then writer 2 crashed again. So in production, it would have led to duplicate notifications, wasted API calls, and no way to prevent it without custom idempotency logic. So this is the problem. Now let me show you the fix. So after.py contains the same pipeline, but is using Agentspan. So as we discussed earlier, when we use Agentspan, this Python script acts as a worker. And we have to spin up Agentspan server separately. And doing it is really easy. So if you look at their documentation, there are 3 really simple steps. First step is installing Agentspan. Let's copy this, go back and run it. So this is done. Next, you can verify the setup by using Agentspan Doctor. Step 2 is setting the LLM API call. Because while using Agentspan, this after.python or this Python process is not going to make the LLM calls. Instead, Agentspan will make the underlying LLM calls. So we need to export OpenAI API key or any other API key that you are using. So I have already done that. And the third step is starting our Agentspan server. Just copy this, go back and run it in the terminal. And then you can access this dashboard on localhost 6767. Here you can find all the executions, the queue monitor, all the agents, their definitions, all the credentials, and you can in fact run an agent from here. And the fourth step is running your first agent. This is basically the code that we have already set up. So this is the code we have in after.py. At the top, we are importing agent, agent runtime, and tool from agentspan.agents. And we have the same 2 tools at the top that we had in before.py, web search and send notification emails. Along with that, we have 2 more tools, write draft and edit article. Now this @tool decorator from Agentspan will register each function as a worker task on the Agentspan server that we just started. So when the server needs a web search done, it dispatches a call to your worker, or we can say this Python process. Then your function will run here and the result goes back to the Agentspan server, and that result is persisted in the memory. And if this worker process crashes after this tool completes, this tool will not run again. And just to clarify again, what we are calling worker here is the Python process which starts when we execute after.py. And then this is where we are defining our pipeline. So there are 3 agents, and pipeline is defined by using right shift operators between these agents. This right shift basically chains all of these 3 agents sequentially. Researcher's output will be fed into writer, and writer's output will be fed into editor. Now, before we look at the next part, remember, the Agentspan server is already running in a separate terminal as a result of this command. So that's a separate process on localhost 6767. Now this Python script acts as a worker and connects to it. So there are 3 key methods and the order matters. First is runtime deploy. Deploy sends the pipeline definition to the server. After this call, Agentspan server knows that there are 3 agents, what tools each has, what model to use, and how they are connected. Now this piece of code is checking if there is a stalled execution from the previous crash. And it is calling getStatus function on the runtime. Runtime is basically agent runtime, which is coming from Agentspan. And here we have defined the Agentspan server URL. Next, if there is no stalled execution, it will start a new one. So runtime.start tells the server, run this pipeline with this prompt. The Agentspan server creates a conductor workflow, it assigns an execution ID, and the server-side LLM loop begins. The server makes the first LLM call to decide which tool to call. But the tool functions live here, in our Python process, not on the Agentspan server. So the server creates a task and it waits for this worker to pick it up. And that's where runtime.serve comes in. This is when our Python process becomes a worker. It registers all the tool functions, web search, send notification email, write draft, and it starts polling the server every 100 milliseconds and keep asking question, do you have any task for me? The server says yes, run web search with these inputs. This Python worker runs the function, sends the result back, and the server persists it and moves on to the next step. And that's the simple code. Now I'm going to crash it live and we'll see if any of this actually works. All right, so our Agentspan server is already running. Now let's run our python.py and start the pipeline. And as soon as our researcher agent is done with web search or sending the email, I'll interrupt and cancel it. So the email was sent and I have interrupted it. And if we look at the dashboard, we see two executions in running state. Now let me explain what's happening. The first one is researcher, writer, editor. Now that's our pipeline. We can think of it as the parent. It manages this sequence, like run researcher first, then writer, then editor. So this is the parent node, and then it started the researcher agent. But this agent is not complete yet. And we can click on this view execution button on this researcher, and it will take us to that second active execution. So this is what we have here. Now this is the researcher agent itself running inside the pipeline, and it has its own LLM loop. So it makes a call to GPT 5.4 and finds out which tool to execute. Then it tells our Python process to execute web search, and it gets executed there and results are sent back to Agentspan. So this tool is marked done. And then it makes a second call to LLM to find out the next step. And then it decides to execute send email tool. So it tells our Python process to execute it and gets the results back. And once that is done, it gets into the third turn. So it makes another call to LLM and decides to make another call to web search. But while this was being done, we crashed the process. So it is stuck in active state. Now we will restart our Python process and we'll see that it will resume from this tool itself and mark it done and proceed to the next agent in the pipeline. And I'll run the same command python after.py. And this time I will not interrupt it. So as you can see in the dashboard, we still have those two running processes. And if you look at the researcher, so it called web search multiple times. But the important thing to note here is that it did not replay the send notification email tool again. And we can see that all the other agents are complete too. So if we go to the writer, it used two loops and it was complete. And this is the editor agent. And if we look at the root level pipeline, all of these three agents are now complete. Now let me put this in perspective. Researcher agent took a couple of minutes to complete and used over 8K tokens, and it was a naive example. And without Agentspan, all of that would have been wasted. You would have restarted the pipeline from scratch. With Agentspan, you get all of those savings and none of your tools or agents are replayed again. But what about when the process is fine and the LLM provider has issues? But with Agentspan, the server handles this automatically. 429 and 500 errors are classified as transient by default, and Conductor retries them with exponential backoff. Your code doesn't need a single try catch for transient failures. The workflow pauses, waits, retries, and then continues. So every execution is fully recorded. On the dashboard, you can open any execution, you can switch to debug view, and you can see everything which was happening behind the scenes. You can click on any of these nodes and look at the summary, input, output, logs, JSON, definition, etc. And all of this turns your 30-minute debugging session into a 30-second visual check. You can see the entire timeline, agent definition, and the complete agent JSON that you can download from here. Now here's what you get with Agentspan: crash recovery and durable execution. It enables your agents to survive process death. You get automatic retries with exponential backoff for rate limit errors or 5xx errors. You also get mechanism for human-in-the-loop approvals that can wait hours or days without blocking a thread. And you get the flexibility to configure guardrails for validating LLM output and a built-in observability dashboard. And for multi-agent orchestration, it's not just sequential pipelines that it supports. Agentspan supports parallel execution, LLM-driven handoffs, router-based delegation, swarm patterns with condition-based transitions, round robin, and manual human selection. So if you're building pipelines with complex architecture, you are not losing any flexibility. It also gives you event streaming, a testing framework with mock runs and replay, and support for 15 plus LLM providers. You can find all the resources I have used in this video in my free school community. You can find the link in the description. If this saves you a crash, start the repo, like the video, and subscribe the channel for more content like this. In the next video, I'll show you what happens when your agent needs to wait 48 hours for a human to approve something, and why every framework gets that wrong. That's it for this one, and I'll see you in the next one.